God morgon allihopa och välkomna till den här veckans Snacka Kubernetes med Conoa som kommer att fokusera lite grann på säkerhet, eller väldigt mycket på säkerhet. Vi kommer byta över till engelska såklart för presentationer. Denis svenska behöver förbättras lite grann innan vi släpper lös honom på det språket. Som vanligt så spelar vi in och postar våra webbinarium på YouTube. Frågorna kör vi i Q&A-sektionen precis som vanligt och vi svarar på dem as we go eller tar dem på slutet när det passar bäst. Och Kubernetes t-shirt står alltid på spel för dagens bästa fråga. With that, Dennis, I'll switch to English, so hopefully you'll understand what I'm saying. I'm going to hand this over to you. I've asked people to put the questions in the Q&A section, and I'll be reading them for you whenever they pop up.
Perfect.
So let me end my presentation here. Stop share there. And the screen is yours, Dennis.
Thank you very much. Let me share my screen. So welcome everyone and many thanks for joining. My name is Denis Magin. I'm the technical lead here at Sysdig, responsible for Nordics, Eastern Europe and DACH region. And I've been with Sysdig now for over 2 years. And before joining Sysdig, I was working for Docker. So kind of initially when containers were introduced, I was doing this the first hand and experienced as a lot of interesting stories and challenges around security and monitoring of containerized applications, both Kubernetes and of course Docker's form. So in today's topic, we're going to talk about Falco. And for those of you who doesn't know what Falco is, so Falco is basically a Cloud Native Runtime Security project. So de facto Kubernetes threat detection engine. It was founded basically in 2016 by Sysdig, and our founder of Sysdig, of course, is Loris Giugiani, who was also co-creator and co-developer of Wireshark. So, and it's you're gonna see later in the demonstration a lot of similarities and from the kind of infrastructure point of view with how we capture the system calls. Both Falco and Sysdig are open source projects. Sysdig is still owned by us, but Falco, of course, was donated in October 2018 to CNCF. And now it's kind of moved to the incubation level project in January 2020. We have a lot of contributors and the project is growing very, very strong. And recently, let's start with a diagram showing the main components at the base of the Falco and open source Sysdig. So Falco and Sysdig operate on top of the same data source, system calls. This data source is collected using either a kernel module or an eBPF prop. Then the two methods are equivalent in functionality, but the kernel module is a tiny and a bit more efficient, while eBPF approach is safe and more modern. And as you know, eBPF is became kind of standard part of Linux kernel since version 4.11 and since version 4.14 it's fully usable, I would say. Falco contributed, Sysdig also contributed a lot to the development of eBPF and we even wrote a book on that. So before, let's continue further with the functionality and how this looks like. So before being consumed by Sysdig or Falco, the collected data needs to be enriched, right? So for example, a file descriptor number needs to be converted into a file name or an IP address. And of course, this is accomplished by the two libraries, libsysp and libscap. And the green boxes in the diagram identify what is now owned by the Cloud Native Computing Foundation after Sysdig donated beginning of the year, both libraries here. And basically kind of to display this in a more kind of high level perspective, because to go deeper, it will take a lot of more time to explain how this works. So same for applicable for Sysdig agent, like enterprise agent, and for the open source Falco. Basically our agent is being deployed as a daemon Z, or like sits on top of kernel, and consumes the information of the different coming from system calls, either, as I said, using eBPF prop or our own kernel implementation. And that means that everything which is running on top of the host, right? So which is basically everything, is creating a system call, and this system call is being detected by us. And the main advantage here, of course, is the performance, because since we are kind of natively consuming the system calls on the kernel level, kind of non-blocking way of consuming this information, our approach is kind of, let's say, non-invasive here. So we do not kind of slowing down the applications, like for example, ptrace or strace, but really kind of natively analyze the information stream coming here. And of course, those different metrics and events are being collected, makes everything which is happening on top of the host completely visible. So saying if you launch an application or just natively on the host, or if you start a container with a task side, everything of this is visible, because this all creates a system call. That means if an application, for example, is writing something to non-persistent disk inside a container, or another application is being accessed from outside, coming outside of the monitored or secured environment, all this information is being captured by us and detected and sent, in this case, to the Sysdig Secure backend. So that means, as you can already think, that there are two kind of differences between the open source and the Sysdig Secure solution. So open source Falco is basically kind of used to detect malicious events coming inside, coming from the different system calls detected by us on the host. The Sysdig Secure, or kind of enterprise Falco, is kind of a more I would say, granular solution in terms of integration with the different environments. So it's a kind of a full suite which helps you to analyze those events coming from the system call data, and also integrates seamlessly with your existing environments, for example, like SIEM solutions, alerting, and so on and so on. Of course, on the open source Falco, there are also projects which are kind of related to this, to the alerting and other integrations. But the difference here is that basically everything is coming out of one solution. So just to kind of summarize how this works, or like how this looks from our enterprise point of view. So the Sysdig platform, which is based on ISO on open source pillars, starting from the Anchor engine, Prometheus, Falco, Sysdig, and of course Cloud Custodian now, kind of consumes all the different data sources coming like from CI/CD, like from the standard secure DevOps approach. We have also application integration in our agent embedded, which also has Falco integrated as well. Sysdig. We do kind of support basically all runtime environments and Kubernetes flavors, and of course all different clouds. And to kind of demonstrate how this works and how this looks from the perspective, I would just move into the live demo. And during the live demo, if you have any questions, please post those into the chat, and I'm happy to answer those. So let's start. So since I mentioned next to the Falco, the Cloud Custodian, another open source project which is being integrated. So our goal from the Sysdig platform, the Sysdig solution here is to kind of gather all events which are coming from the different data sources which I mentioned before, including Falco and cloud environments, and display those, kind of combine those events into a very, let's say, granular view, which gives us the possibility to immediately see what is happening in our environments. So like in my case right now, we're looking on 4 different clusters actually in my demo lab, and we have a lot of activity here. And all of those activities coming from the Falco rules, from our policies, which are based on the Falco rules, and of course from the information coming from Cloud Custodian, and those are matched against and being visualized here with our insights view. So that means in my 4 clusters right now, I can see what is going on based on the policies which I have configured. And I would like just to demonstrate how this looks like. So let's say if I have the cloud activity, cloud user activity, but also Kubernetes activity and composites view. So that means if you, for example, would run the solution in your on-premise environment without cloud activity, you would still be able to see either Kubernetes activity, which is happening inside your clusters based on the policy, but you could also see the composite view, which is also quite interesting because this is more related to the workload, what is happening inside my environment. So, and I would like to show you a specific example, which is based on a terminal shell in a container, which kind of reflects what is happening in my productive environment. So let's assume for a second that we are kind of securing a couple of clusters because our solution is multi-cluster, multi-cloud capable, and we have a production workload running in our terminal shell and container namespace, just for demo purposes, and somebody opening a terminal shell in that. So, for example, I could easily go now here and type in terminal shell, and this would exactly show me what is happening here. So as you can see right now, we have detected that in our cluster demo cube AKS in the namespace terminal shell and container, and this deployment, we have terminal shell open. So that means I could immediately see what has happened here. So this is kind of, again, a composite view or like a combined view based on Kubernetes activity. We have somebody has deleted the bash history, and at the same time, somebody has opened the terminal shell and container. So this is kind of an insights view, but from here actually I can go and show me the events which are coming from the Falco rules. So we have a trigger here on the delete bash history, which I can also kind of display what is happening here with a summary of triggers on the Falco rules. As you can see here, this is the Falco rule type syscall. We have the rule name, delete bash history, which has been triggered. And of course, we have a full summary of the scope where this is happening. So right now, let's say, if I would like to understand what happens here, so I have all the information, starting even from the process name, container ID, and container image. At the same time, I can do the same with my terminal shell and container event, which has happened, again, describing basically the same information. And this summary is also coming from the rule itself. So, and from here, I can actually go in and respond to this event, kind of understanding what exactly was happening here. But before doing that, I would just like to show you the rule first so that we can understand it, and then kind of go through the different stages on understanding this event. So for that, I would like to go to the policy and show you the runtime policies. So these are the runtime policies which are constantly updating with our solution. They contain, as the policies containing basically a lot of policies based on the different topics, based on different texts as well. But in our case, I would like just to highlight the specific terminal shell and container policy and edit those so that since our solution is again a Kubernetes native, we are also consuming all the different text or labels in your environments. And in this case, I've kind of narrowed down the scope on this specific namespace, the terminal shell and container, and imported my rule. And this is exactly the rule which I imported from the library, which I'm going to show you in a second, which kind of has all the different Falco rules coming also from open source project, but also from an enterprise Sysdig perspective. So as you can see, the syntax is fairly simple because all Falco rules are written in YAML language. We have defined the rule name, the terminal shell and container. We also have the condition, how this rule looks like. So this is a kind of a spawn process. I kind of click on that one. It displays me the condition for that. So as you can see, this is event type execve. And I can also modify those rules, kind of append no additional information on the fly. So this is, again, kind of displaying how the differences between the open source Falco and our enterprise Falco approach, where everything is kind of already integrated in a centralized solution. We have then condition end for the container, so because it should not running on the host. Shell procs, which are again being defined by us on the shell libraries macro, which again can be modified. So if you have anything specific, any new shell binaries which you can add, you can always add those to this to the macro. And we have, of course, like this is interactive and container entry point and not user expected termination and container conditions. So this is basically again additionally our macro, which gives us the possibility to exclude false positives. So let's say if you would like to add some conditions which are not being triggered by the rule, you can always do that. And then of course you have the kind of output which then displays in the policy and description and text as well. But the more interesting here, of course, are the actions which can be taken on our side on the Sysdig enterprise from the enterprise view, because Falco rules basically detects, but our enterprise approach is kind of going also into protection and prevention. So on the container action, I can basically do nothing, like the standard approach here, which is used here for the demonstration purposes, how this would look like. But I could also actually go and kill, stop, or pause the container. And the cool thing here is that, so this is basically a completely non-invasive approach. That means you container images do not need to be modified at all. And you can basically do it very easy on the container runtime. That means if somebody, let's say somebody tries to connect to you via kubeexec to any of your ports which are being protected to those internally or external access, doesn't matter. The Sysdig agent would detect the system call using the Falco rule and issue then a docker kill command on the engine level. That means the attacker, or like the person who's trying to access a container, would just have the kubeexec hanging API because container is killed. Kubernetes will then restart the container, and then the next call will be detected to the terminal shell in the container, and it will be killed again. And of course, as mentioned before, or like in the description of today's session, we have also the functionality from Sysdig for the capture one. And this is where you're going to see the similarities to Wireshark. We have capture enabled here, and the capture is important for the forensic analysis. As you know, the containers are kind of ephemeral. That means anything which happens in container, which was not written to the persistent volume, is disappearing after the container kind of the end of life, reached end of life, or has been killed. And this is exactly the issue which kind of makes the most headache. How do I understand that I have been compromised, for example? And then, of course, the next step is understanding of the what exactly was compromised. So the kind of two different ways, or like two different topics which need to be covered: understanding that I've been compromised, maybe protecting me from being compromised, but as understanding exactly how this affected me. And Sysdig capture here is exactly responsible for these things. That means since we are kind of having our agent or the host on all of the hosts inside the cluster running, and on the host where this policy has been triggered, I can create a Sysdig capture which creates basically a dump of system calls, of all system calls on the host itself. Meaning I have then all information, in this case, 10 seconds before the event has been triggered and 20 seconds afterwards. Because we're using the ring buffer here, you can go back a little bit depending on the amount and utilization of the host, and kind of record the baseline functionality of like baseline system calls before the event and afterwards. And of course, I can do integration with notification, and I can filter out some specific processes, but this is not the topic of this session. So just to summarize, for this namespace, I have the policy scoped on this terminal shell and container namespace. I've imported my library, and I have configured the capture. So if I now go to events, for example, here, I've already kind of found the specific events I was looking for. So as you can see, yesterday somebody opened a terminal shell and container. So basically the same information which I've seen from the insights. I can also see a filter here from the events, and I've selected the runtime policy here as event type. And from here I can actually now see the same information which we've seen before on the insights view. The difference, well, like what I would like now to understand here is the who opened exactly the terminal shell and container. And since we are being integrated also with kind of Kubernetes audit, so this is again the information which as open source, both open source and our enterprise agents are consuming this information from the Kubernetes audit logs. We can match the data from the system calls collected against the data collected from the Kubernetes activity audit, and provide that, so a very granular view of what's happening in my during the policy, when policy was triggered. So in this now we are being brought to the activity audit, and here you can see that exactly the event where this happened. We can see the hosted containers here. So this was the affected host, and this was the affected container. So even if this container is not existing anymore, the information is still available and gives me a full understanding of what's happening here. And as you can see right now, there's a lot of information to scroll down, because we capture on the Falco side, we capture all information, not only on commands, network activity, and kind of kube exec access, but also the all file activity. That means deleting and creating files was also kind of captured by us. And to give kind of this information a more granular view, we can actually drill down to the specific event to show everything kind of chronological order, not reverse, but kind of to the next one. And now we can see that Mary Jo user coming from this source IP was opening, basically accessing our Kubernetes API and opened the terminal shell here. And you can see all the information coming from the Kubernetes. You can see the even the user agent which has been used, as well as the source address, and basically the same summary of the scope here. So just to make this a little bit more visible, I just gonna select only command network activity and kind of exclude the file activity here. And now we can see exactly what happened here. So Mary Do opened terminal shell in this container under this directory, and then executed ls, downloaded this archive from the GitHub. As you can see, the full command line executed in the container, even with like additional details here. You can also see the network activity again coming from the system calls with the client and server IP addresses, and of course all the commands which were being executed afterwards. So basically deleted the old directory, extracted the new archive, and then basically after leaving the shell, the history was deleted here. And the interesting question here is to ask, okay, now that I have this information, I would like to understand what has happened, what were the contents, for example, of this archive. Maybe I can try to download this archive, but if it's not available anymore, for example, 4.3 or 4.4, if it was something really malicious, then I have quite an issue. Right. So for that, I would now need to go to the container and hope that container is still running in my runtime to understand what were the modifications there. But the issue is, if the container is already gone for many reasons, I don't know exactly what happened here. I can still actually go and display again the file activity here, which would show me what was happening here, right? So kind of let's see, close that one. But I cannot see in the contents of this file. So basically, I could guess what exactly was that, but it does not really give me a full understanding of that. And exactly for this reason, we have enabled this capture before, which I was talking about. So moving back to the events, going to our terminal shell container. From here on the response phase, I can actually go to the capture, and the capture has been created and with our policy. And as may be important to mention that all of our policies are stored locally on the agent. So basically the agents connect to the backend in this case. downloads the policy and stores it locally. So that means even if the connection from the secured the clusters which are being secured to the backend has been terminated for some reasons, the environment is still being protected. So when the policy was triggered, we created the capture, and the capture was then uploaded to the Sysdig backend and now deleted from the host itself. So now we can actually go to the capture, to view capture with inspect, so online, or download the capture and see exactly what's happening here. And here you will see the similarities to the Wireshark. So even the name is a kind of Sysdig SCAP versus PCAP. And what we have here is basically a full dump of the system calls for the duration of 30 seconds in total, which we have configured in our policy from the host. Right now, it is by default filtered in this view to the container ID itself, which is relevant for us. But if I like, I can remove the filter here and display me all the system calls which have happened on the host for the 30 seconds, so including all the processes, containers, logs, and so on and so on. That means based on this separation on the different topics, like kind of general activity, file activity, network connections of network applications, security events, as you can see from like executed commands, interactive commands, ZNN's invocation, and deleted files, but also for performance and logs and infrastructure events. That means not only this can be used for kind of forensic analysis, but it can be as used for troubleshooting or understanding behavior. So that means the capture can be created manually as well for analysis purposes or like maintenance purposes, troubleshooting purposes, but can be also used, of course, for the forensics to understand exactly this specific event as we're talking about terminal shell and container. So that's why I was now kind of, let's say, I know already what I'm looking for. I'm looking for the executed interactive commands, but if I would not know what I'm looking for, I could actually start analysis and say, I would like to see the secure event notifications, which we are looking already, we know that. So the event happens over here, but I can start actually like this: deleted files, NetBias, maybe active network connection, maybe new NetBytes in, right, and files in. So here already I can see kind of very interesting stuff. So the files have been deleted, right, and we have active network connections. And of course, I can now kind of highlight executed interactive commands, notifications, and I know that the event I am looking for is exactly here. So that means now I can actually start kind of going further with analysis on the kind of forensics side, and I can drill down on the executed interactive commands. And as you can see, so these are basically the same comments which you've seen before in the activity audit, with the difference that now these comments are being displayed from the host level, and we can see that the user, the container basically was run by user www data. So it's obviously it's Apache running there, which where the terminal shell was opened, and we can see all the same comments which we're looking for, before. With the difference here that since we captured the system calls and created a system call dump for the Sysdig capture, I can now drill down exactly in this commands which have been executed. So since it was target set, so we need to drill 2 times. So for the JZip first, and then for the tar. And now I can see again the same information which you've seen in the activity audit on the files which were extracted, with only difference here that since it was system calls which were captured for the Sysdig capture, I can go actually into IO streams and display me the contents of this file, meaning that clicking on the IO stream, I can now see the contents of my let's say archive, which has been extracted on the non-persistent disk inside a container which is not existing anymore, and this gives me a full understanding of the full event. So Mary Doe opened the terminal shell. So let's say either she was coming from external or internal. So it then depends. Was it a man-in-the-middle attack, for example, or were just the credentials compromised? And somebody externally accessed my Kubernetes API, then extracted this archive inside the container, which is basically a rootkit. And even if this container is not existing anymore, I was alerted, and now with the forensics capability, I can understand exactly what has happened here. So basically, if I go back again, I can even see what kind of license that was, which just a little bit funny. So it's a GPL, yeah. Anyway, so this is basically a summary how Sysdig kind of utilizes together with open source components on Falco and Sysdig captures functionality to give you the full visibility of the event with the different Falco rules. And maybe the last thing which I can show, since we're already coming to the end, all the different Falco rules which are available. So here on the Falco library, we have basically the full summary on the different Falco rules mentioned on different tags, it's basically so everything related to Kubernetes, for example, can be kind of enabled and included. So that means you can build a policy which consists have different rules included, and creating policies also quite easily here. So let's see if you would like to see, let's say, so if the custom role was deleted, right? For example, so these rules are already pre-created and can be used for both open source Falco, and of course the enterprise Falco as well. Any questions so far?
No, we have a very shy audience today, or everyone already have the T-shirt. I'm not sure which one it is. We're getting a question now just because of that. What parts of what you've shown are available in Falco and or Sysdig?
So what I showed you basically so what we're looking right now is the enterprise Falco solution. That means this is our solution Sysdig is offering based on the open source Falco, Sysdig capture, and of course Cloud Custodian as well, Prometheus and Anchor Engine. I showed you basically the components which were related to the Falco, open source Falco solution, which are being kind of detecting the rules. So this is the go to the rules library and show again the terminal shell in the container. So this is basically a part of open source Falco. The only difference here is that in our solution, I've already integrated into the UI into our platform. I can easily kind of extend the scope to my multi-cluster, multi-cloud environment, and at the same time, I have the possibility to respond on the detection. So not only kind of providing the forensics visibility as open source Falco does, but also react on those. So that means if I would go now to the policy which I showed you before on the terminal shell, and create or like modify it and set the container action to kill, that will then kill the container and will not let the attacker go inside the container, still triggering the notification, but the capture will not be created. And the capture, of course, is as a Sysdig part of Sysdig, which is as an open source project. But this functionality basically needs to be kind of created by like manually.
Another question, is the user interface available in the Falco open source version?
No, unfortunately not. So the user interface is completely kind of owned by us, but there are different, let me show you another one. 1 second. So my colleague was doing a workshop on open source Falco a couple of weeks ago, and let me find you the components. Okay. So basically, this is how it would look on the open source implementation of that using nuts, for example. But everything else, is like with the UI, it's basically not is part of our enterprise solution.
Okay, so I have a question, Dennis. Security is pretty complicated in containers, and there's a lot of companies and technologies out there to kind of starting to address this. What, in your view, would be the 1 or 2 reasons to consider looking at Sysdig?
Sysdig brings you kind of a unified single pane of glass solution, which covers the full stack, starting from the cloud accounts, and cloud adoption is kind of became standard now, running containerized workloads, be it serverless or just Kubernetes as a service, and of course going then through the Kubernetes stack to the host, to the process level, only using a single agent. That means you have no need to modify your existing environments. The deployment of our solution is quite easily, basically just deploying the daemon Z, and that's it. And of course, we're completely based on open source. So and that's the key differentiator to our colleagues from the competition.
Okay. If you want to run this on-premise versus running it in the cloud, is there any differences to be aware of?
I mean, this is a good question. So I would say generally no, but since our SaaS solution is our upstream project at the same time, you need kind of there are some functionality which are being backported. So let's say, for example, the insights which we have already here available in our SaaS solution will be released with the next version. So you have a kind of a delay between 1 to 3 months on the feature parity, but usually I would say no. So I have actually an on-premise deployment running already here, but I won't show that. But basically no, I would say. So there are differences only in the feature porting, but no difference at all. So you can run Sysdig backend completely air-gapped in your environment with all functionalities. Of course, the downside of this is that you need to provide computer resources and storage resources for Sysdig backend for that. But that's it.
Yeah, I got a question here. I think you partly answered it. Is Enterprise only hosted by you, or can we self-host? And if so, what backend storage options are available?
Yeah, maybe I'm gonna open that one. So I have this is my environment here. Maybe okay, yeah, we were logged in. So basically, we are kind of agnostic, I would say, to the storage, because usually if you have a working Kubernetes or OpenShift cluster, you have a storage provider, you have a storage class configured, and it means that everything is being deployed as Kubernetes native deployment. That means the Sysdig is being installed again as using our installer automatically on a new environment like Kubernetes platform. Let's go to the pods like deployments. And that's it basically. So you deploy our backend on your on-premises infrastructure. We have kind of a couple of stateful sets which needs to be created to store the persistent data. But that's it. It's nothing complicated in that case. So here you go.
Okay, so if you want to test drive this or play around with it, where can you get it?
So usually we say to go to the Sysdig.com and /trial. So actually, so this is we are offering you basically possibility to start the trial as using the enterprise functionality here. At the same time, for the CSPM, we actually even give you one, I think, one account like lifetime for free. So on the cloud security or the content, yeah. But it's easy to start from here, because if you want to start test the functionality itself, the easiest way is to start with the SaaS solution. You just deploy the agents in your environment. The agents are being communicated over TLS connection to the Sysdig backend, and we do not send any information from kind of sensitive information, not from image scanning and so on. So only the metadata is being sent, and at the same, just only the metadata metrics. That's it.
Okay. Thank you, Denis. I think we'll round that one off. If I can take back the screen. Big thank you for taking the time to show us Sysdig this morning. I'm just going to remind people about next week. So let me see. And of course, if there's any questions that pops up later, feel free to reach out to me, and I'll get the questions over to Denis and get them answered. So next week, we're going to do another hot topic, which is Zero Trust Network. So Niklas from Conoa is going to be talking about that. So I'm hoping we will see some more people coming in next week. And with that, I'm gonna end today's session. Thank you everyone for attending. Thank you, Dennis, for attending, and hope to see you next week again.